Have you ever think about, can a baby see before it's born? It turns out, not only can they detect light in the womb, but their brain might already be paying special attention to faces. A new study from University of Turin found that fetuses as early as 26 weeks show a preference for face-like shapes. This way earlier than we thought facial processing could begin. Why does this matter? Faces aren't just pictures. We use them to connect, to communicate, and to build relationships. If the brain starts turning into faces this early, it could reshape how we think about early development, and even how we connect with babies before they were born. Until now, studies focused on infants after birth, but this research asks a question we've rarely considered. When does our brain first start to care about faces? The researchers wanted to find out when this face preference begins and whether it's tied to the thalamus, which is a deep brain structure that helps us decide what to pay attention to. So what did they do? They ran 3 experiments with pregnant women. Using ultrasound, they checked how baby eye moved in response to light patterns projected through the womb. The first experiment. 37 weeks fetuses were shown a triangle of dots resembling a face or the same triangle flipped upside down. The results show that, even before birth, babies looked more often toward the face-like shape. Second experiment. They tested how light moved, either flashing or steady. Babies reacted more to continuous light, which may feel more like how faces appear in real life. The third experiment. They studied baby at 26, 31, and 37 weeks. The face preference grows stronger as they developed, linked to the growth of the thalamus. This suggests that, even before birth, the brain is learning what matters. The progression from 26 to 37 weeks shows that this is not just a reflex, but a developmental process. This study showed that our brain may start organizing social information much earlier than we believed. Even before we see a real face, our brains may already be preparing to meet one. This challenges what we thought we knew about early brain development. So, what does this mean beyond the lab? First, it gives us a new insight into brain plasticity. If preference begins this early, we may better understand how social circuits form at the start of brain development. Knowing this could help support healthy growth from the beginning. Second, it raises possibilities for early detection. While this research is not diagnostic yet, it opens important questions. Could early visual preferences hint at later developmental differences, such as autism? If so, simple light-based tests might offer an early glimpse into brain development before birth. And finally, it changes how we think about prenatal bonding. Parents often focus on music and voice, but now we know babies might also be watching, tuning into light and shapes. Light simulation could one day become a new way to connect, even educate our babies before we meet them.